All right, so in this problem, in order to do dq dt, since there's only one variable, that is one total independent variable, which is t, obviously we're going to find dx dt. I'll go ahead and bust them out because it's pretty straightforward on this problem, I think. It's not, in other words, it's not as bad as some of these problems are. Some of these problems are just gross to do. So here are those guys there. Those are all derivatives with respect to t. So then I need so what I need to find dq dt, I'm going to write down here where I can actually write it. It is long because you're right, it's dq dx times dx dt plus dq dy dt plus dq dz dt. And you're right, it's going to be ugly no matter what you do. So the derivative of these are always going to be that thing on the bottom, obviously. Well, it's going to be 1/2, so it's going to be 2 out front, x squared plus y squared plus z squared. And then the derivatives of the inside will be either 2x, 2y, or 2z. Go ahead and do it on a calculator, but that's what it's going to be. So this is going to be x over this. And then times cosine of t, right? So that cosine of t, I'm just going to drop the cosine of t up top. Oops, cosine of t, I'm just going to drop it up top. For now, hang on. And then plus, and then we're going to actually do a little more substitution here in a minute. So we're not done, but we're getting there. Okay? And then, of course, this guy. And then there's going to be a minus sign on top. And actually, I'm going to fix this to a negative. And then, the times, I don't really need it if it says that, do I? And then minus again, but this time it's going to be z sine t over this. Okay, that's pretty cool, right? Now, what is x? Well, x is sine t, so I'm going to go ahead and substitute that in right here. And then y is cosine, so cosine sine, right? And then minus, and z is also cosine. Okay, and it's all over the same denominator, right? So I'm just going to go ahead and plug those in just to see what happens. Cosine, sine, oops. Right? This is one of those problems that the book puts in just to see if you're still awake. You're probably not. That's no offense. It's just luck kids not ready. Hey, sine squared plus cosine squared. Hey, that's 1. No way. Way. Yeah. Yeah, so let's think about that for a minute. 1 plus cosines plus 2 cosines. Nope, that's about all I can do. That should be all I can do on this problem, okay? Now, yeah. Let's plug in a value that we know will work. Let's do 45 degrees or pi over 4 if you prefer, which is, of course, root 2 over 2 and root 2 over 2 are our values for that. So we plug them in, you're going to get, that's a half, it's negative a half on top. On the bottom, you're going to have a half plus 1 is 1.5, which is 3 over 2. The square root of 3 over 2. Well, hold on. This guy squared is going to be 2/4. Right? Right. Which is 1/2. Yes, 1/2. So square root of 3 over 2 like that, I guess. All right, let's leave it like that for now. Okay, so if you plug in x up here, you're going to get square root of 2 over 2, square root of 2 over 2, square root of 2 over 2. I think. Well, you'd have to actually plug it in first. So you'd have sine squared plus cosine squared plus cosine squared. And the idea is that if you wanted to, you could do it this way. You could substitute. Sometimes. Sometimes no. If we did the derivative of this guy, again, this is just to check myself, see if I'm right or wrong. As you start down this path, sometimes you wonder, why did I do this again? Sine squared plus cosine squared, though, is still 1. So I'm going to do this. So this looks good for the home team. Times the derivative of this, which is 2 cosine t. Right? So derivative of the outside times the inside. So that's what you have on top. Is that what I ended up with down here? No. No, but we're not done yet. So that would be square root of 2 over 2. And the bottom you'd have square root of 3 over 2. All right, I'm back. Where I plugged this in, it was z times sine right there. You with me? But z is a sine. No, z cosine? No, z. Oh, z's cosine. Never mind. We're doing that right. Never mind. So that's where I left off. This I'm 100% is correct. I'm 100% that is correct. That's 100%. What I'm not sure about is over here in this mess. So just ignore this. This should have worked. When I did this to check myself, that should theoretically have worked. But I think I made a mistake somewhere in that mess. They should work either way. This is the way I want you to do it. Okay, just follow the pattern, and then you're done. Okay, ignore the last part.